Hello, this is Mr. Henry, and this is lesson 3.2. Today we're looking at solving two-step equations. The last lesson we were doing one-step equations, and what we saw is that we always do the opposite of what's happening to the variable, and that got rid of the math. So these forget the goofs are examples of that. So let's see here. This first problem, let me just bump down to have some space. The first problem, what we learned yesterday was we should always do the opposite. So if my variable here is being added by 6, I should subtract 6 on both sides. This goes to 0, and p equals 9 minus 6 does not equal 15. Should be 3. And if we'd plug that back in, we should check to see 6 plus 3 is 9. So that would be the correct answer. Okay, number 2. If I would add 9, r equals negative 12 plus 9 is negative 3. That one's correct. Number 3, we need to divide by 4, and 36 divided by 4 is not equal to 8. 36 divided by 4 equals 9. And number 4, the variable is being divided by negative 3, so we're going to times by negative 3. Times by negative 3. The multiply and the divide cancel. H equals negative 2 times negative 3 gives us a positive 6. Okay, so that's a nice refresher of what we did yesterday. Make sure you have your essential question copied down. How do I solve two-step equations? Alright. Vocabulary. We've got 3 vocab words here. Not all of them are new. The first one is, today we're talking about like terms. Now, like terms are basically two terms with the exact same variable. Two terms with, with the exact same variables. And we'll see what that looks like here shortly. So, for example, if I have 3a minus 5b, those are not like terms because they have different variables. But if I have 3a minus 5a, those are like terms, they have the same variable. And then what we'll be able to do is simplify and say, okay, 3a's minus 5a's is a negative 2a's. Input and output. This goes back to, I think, chapter 1, talking about functions. The input is what goes into the function. It's called the domain. So input goes into a function. Another name is called the domain of the function. And it's also usually the x variable. So usually x. And then the output is just all the other stuff from chapter 1. So input goes in, it's called the domain, x variable. Output, well, instead of going into the function, it's what comes out. What comes out of a function. Instead of domain, we have range. And it's usually the y variable. So those are vocab words from chapter 1 when we're talking about functions a great deal there. Functions are going to come back periodically throughout the year, so just don't forget the stuff. Okay, so solving our two-step equations. So what we want to do here is we have our two-step equation. First off, find your variable. There he is. Now, we're still going to do the opposite of what's happening to the variable, but now we have an order we kind of have to follow. Now, eventually we're going to get 5 steps to solving these equations. Today we're looking at a two-step equation, so we're not going to go through all 5. But let me kind of give you a little preview. You can copy this down in your notes someplace. So we're going to get step 1, step 2, step 3, step 4, step 5. Now, today we're going to be looking at just these two, step 4 and step 5. Actually, we'll get up into step 3 as well, I think. So, start with step 4. The first thing we're going to do in most of our problems is once we find our variable, we're going to get rid of the thing that's being added or subtracted to it. Another way to say that is get rid of the other terms. Get rid of other terms by add or subtract. So let's see what that looks like before we move on to the next step. So here's my variable. Now, in case you don't remember what terms are, this equation on this side of the problem has two terms, 6m and 11. Terms are all the things that are separated by a plus or minus sign. Okay, so we want to get rid of all the other terms that do not have a variable, which would be this guy. So we're going to subtract 11. That makes him go to 0. Subtract 11. What's left? Well, if we got rid of this piece, we still have a 6m. And on this side, we have 72. That was step 1. We got rid of the thing that was being added or subtracted. It's another term. By doing the opposite. Okay? Step 5. We're going to get rid of coefficients. By multiply or divide. Now, if you don't remember what coefficients are the number in front of the variable, a thing that's being multiplied or divided by the variable. So here we have a coefficient of 6. We're going to get rid of this multiply by doing the opposite. This, in fact, looks like a problem we did in the last lesson. So we're going to divide by 6, m equals, and 72 divided by 6 gives us 12. Now, if we really wanted to, we could plug this in up there. Now let's just imagine 6 times 12 plus 11, and we think that should equal 83. I'm plugging this 12 in there. 6 times 12 is 72 plus 11 does give us 83. That means this answer checks out. Letter B. We do the same 2 steps. We're going to get rid of the other terms by adding and subtracting, and get rid of coefficients by multiplying and divide. So get rid of add and subtract, then multiply and divide. So let's see. There's my variable. The variable is being divided by 3 and subtracted by 13. So I'm going to get rid of this minus 13 first. So I'm going to add 13 here, add 13 there. These are gone. B divided by 3 equals 27. Now, b divided by 3, the way you get rid of a divide by 3 is you times by 3, times by 3. People who are working too quickly, they try to divide by 3, because they'd say, oh, 27 can divide by 3, and they get 9 for an answer, but that's wrong. Always do the opposite. So these cancel, times by 3 and divide by 3 cancel, we get b equals, and 27 divided by 3, times by 3 is 81. We plug in 81 divided by 3 is 27. 27 minus 13 is 14. It's good. Letter C. 23 equals 19k minus 34. Okay, there's my variable. I will change color. Here's my variable. It's being multiplied by 19 and subtracted by 34. So we're going to get rid of the add and subtract first. So we're going to add 34 to this side and this side. Now these guys cancel out. 19k equals 23 plus 34 is 57. Now we're going to divide by 19 on both sides because we're trying to get our variable by itself. So I divide by 19, cancel. Divide by 19, and k equals 57 divided by 19. It's 3. So we got rid of the add and subtract first, multiply and divide second. Letter D. There's my variable. We're going to get rid of the add and subtract first. Now this one's a bit trickier. We are not going to subtract 14. That's not right. This 14 is already negative. So if we would do this, don't write this down, this is wrong. If we would write that down, negative 14 minus 14 does not equal 0. It would equal a negative 28. What we need to do is we need to add 14 so that these two signs are different. Now when we add and subtract them, they equal 0. You can copy that down. So we're adding 14 to both sides. So we get d over 9 equals a negative 8 plus 14 is 6. My variable is being divided by 9. So I multiply by 9, multiply by 9, these cancel, d equals 9 times 6 is 54. And we're done. Okay, so the two steps we went through, we got rid of the add and subtract first, multiply and divide second. Those things that are being added and subtracted are called the terms, and the things that are being multiplied or divided are called the coefficients. So, I'm going to have you do 4 problems. So, copy them down, pause the video, do them. When you're ready to continue, hit play, and we'll go over them together. Okay, so, letter E. Let's see. My variable is being divided by 3 plus 6. I'm going to get rid of the add and subtract first. So I subtract 6 on both sides. You get h over 3 equals, and 14 minus 6 is 8. The opposite of divide by 3 is times by 3. Times by 3, these cancel. Oh, h equals, and 8 times 3 is 24. Letter F. Times by 9 minus 2, or I'm sorry, plus 2. So I get rid of the add and subtract first. We get 9r equals 36. Times by 9, so we divide by 9. We're doing the opposite. Divide by 9. R equals 36 divided by 9 is 4. Letter G. Our variable is being times by 8 and added by this negative 7. Well, we need to get rid of this negative 7 first. The way you get rid of a negative 7 is with a positive 7. So the signs cancel. This thing equals 0. Plus 7. 8p equals 24. Divide by 8, divide by 8, and p equals 3. Letter H. W is being divided by 4, and we need to get rid of this negative 3. Okay, so let's get rid of this negative 3 first, this other term. So we add 3, we get, now, a lot of people forget about this negative. Don't. It's still a negative, and 7. Now, what are we going to do with this negative? One thing we can do is we can take this negative and we can move him in one of 3 places. Okay, this negative, we can think about it up here. It's still the same thing. We could have the negative out front like we have it in the problem, or we could have this negative down here. That's the one that's going to make the most sense for us because we know how to get rid of that one. So just move your negative down there a little bit. Now, the variable is being divided by a negative 4. Well, how do you get rid of divide by negative 4? You multiply by negative 4. Multiply by negative 4. These guys cancel. We get w equals, and this just gives us a negative 28. Okay? So, I'm going to give you a few problems to try on your own. Do these from the textbook. There's some space on your note sheet. Do them, and we'll get back together here in a couple seconds. Pause the video when you're ready. Hit play. Alrighty. So, we're going to go through these 3 problems right now. There's number 1. So the variable is being multiplied by 5 and added by 9. So the way we get rid of an add by 9 is we subtract by it. This is gone. So we get 5x equals 24 minus 9. Oh gosh, 15. And then we divide by 5, divide by 5, x equals 3. Number 2 says 4y minus 4 equals 16. Got multiplied by 4, minus 4. We'll get rid of the add and subtract first. So we're going to add 4 here, gone. 4y equals, add 4 there, giving us 20. The way we get rid of a multiply is by dividing, and y equals 5. Number 3 says negative 1 equals z divided by 3 minus 7. Ooh, I'm a little sloppy here. Looking at the textbook, not the board. Minus 7. Alright. Well, we've got divide, we've got subtract. We get rid of the add and subtract first. So we're going to add 7, gone. Add 7, z divided by 3 equals negative 1 plus 7 is 6. So then we times by 3 here, times by 3 here. These cancel. We get z equals 18. Alright, so those are normal two-step equations. The next thing we're going to do on our note sheet is we're going to do two-step equations, but where we have to combine like terms. So if you look here, on each side of the problem, there's something I can do over here first. I mean, I have 5g's and 3g's. Why on earth would I leave it separated like that? I can just say, oh, well, over here I have 8g's. You can. That's what combining like terms is. You take the things that have the exact same variable and you combine them together. You're using your normal integer math. So if the signs are the same, you add. If the signs are different, you subtract. So when we do that, 5g and 3g gives us 8g. We divide by 8, divide by 8. You know, this is like a one-step now. Get rid of the multiply by dividing, so g equals 3. Okay. Now we can actually go back up to our rules that we had, that we wrote down, Rule 4 and Rule 5. We can add a rule about combining like terms. It's actually step 2, combine like terms. So say combine like terms on each side. Okay. So we combine like terms to get the variables have the same variable together. Then we get rid of the add and subtract. Then we get rid of the multiply divide. Now, as always, if one of these things doesn't apply, like for example, that problem we just did a second ago, there was no add and subtract to get rid of. So you just move on to the next step, kind of like order of operations. If there's not one of those things, you just move on. Letter B. Well, I've got negative 9r and a positive 3r. A negative 9 and a positive 3. If I combine those two things together, it gives me a negative 6r. So I combined like terms, negative 6r. So that's negative 6 times by r. So I'm going to divide by negative 6 to get rid of the multiply. Divide by negative 6. These cancel. And r equals a negative 2. Okay, A, B, C, D. So letter C. Well, here are my variables. I've got two of them. So I'd like to combine them together because they're on the same side of the equal sign. They're on this side of the problem over here. I can just combine them, add and subtract them. So let's see. 5 minus 7 gives me negative 2 of them, negative 2b's. And now we have negative 2 times b equals 4. So the way I get rid of a times by negative 2 is I divide by negative 2. These cancel. B equals 4 divided by negative 2 is negative 2. And lastly, letter D. We've got 6r plus 5r combining like terms. That gives us 11r. That's times, that's a multiply right there. So I'm going to divide by 11 to cancel out, divide by 11, and on this side, the math gives us negative 3 for an answer. Alright, so now we've seen with combining like terms, we've seen the normal two steps. There will be a couple other few things that thrown in there just to be tricky now and again, but for the most part, that's it. Now the next couple examples we have are, we're going to find the input of the function. We're doing a little bit of a word problem, sort of. So here it says, the output of a function, so you think the output, that was the y variable. The output of the function is 7 more than 2 times the input. Now let's just think about that. 7 more than 2 times the input. And it says that's the output. Write an equation for the function, then find the input when the value, or when the output is 15. So here we kind of have an equation. Input we said would be x. So if I can actually rewrite this a little bit prettier. 7 plus 2x, input is x, output is y. There. We've got ourselves a function. We've got x's and y's and some math. Now it says find the value of this thing when the output is 15. Now output's the y variable. So if I just plug in 15 here, 7 plus 2x equals 15, they want to know what the value of this is. Okay, well, let's make some space. So we're going to find out the value of this. So 7 plus 2x equals 15. I need to get rid of the add and subtract first. I'm minus 7, minus 7. 2x equals 8. And then I'm going to, the way you get rid of a multiply is by divide, these cancel, x equals 4. So I found my equation, there's the equation, and then I found the value when, actually I guess the one above is the equation. There. That's my equation. And then I found the value of that function when y was 15, when the output was 15. Letter B. The output of the function is half the input. So just remember, the input's the x value. So we're going to take half of that plus 6. And that's equal to the output, the y variable. Okay? You can write this way. Another way that some people like to write this, if they're finding half of something, is they can just do, well, they take the x variable and they divide by 2. and then plus 6 equals y. Both of these are exactly the same. You'd solve them, well, kind of the same way. You'd multiply by 2 here, or on both sides, and you'd multiply by 2 on both sides there, too. So it's the same thing. So write an equation of the function. Boom. Done. Then find the input when the output is 8. So if my output, the y variable, is 8, and I'm just going to solve them both. Why not? Just to show you it's the same math. If the output is 8, we're trying to find what was the input. So here I would subtract 6. These go to 0. X divided by 2 equals 2. And I would times by 2, cancel. X equals 4. So I got the answer of x equals 4. The input was 4. Now let's check this other side. Minus 6, x equals 1/2 x equals 2. If you remember when we talked about the fractions, you multiply by the reciprocal. So I'm going to multiply by 2 over 1. So numerators and denominators cancel. Multiply by 2 over 1. We get x equals 4 over 1, which is just equal to 4. We got the same answer. Okay. Letter C, I'm going to have you copy down, pause the video, try it. When you're ready to continue, hit play, and we'll go through it together. Okay, it says the output of the function is 4 more than 2 times the input. 4 more than 2 times the input. And that's equal to the output. There's our equation. So find the input when the output is negative 10. So when this output is negative 10, we want to know what is the input, what is the x variable. So we just solve it. We've got a multiply, we've got an add. So we're going to get rid of the thing that's being added or subtracted first. So we have minus 4, minus 4. Get 2x equals negative 14. Divide by 2, x equals a negative 7. So I got rid of the add and subtract first, got rid of the multiply by dividing, and we're done. All right. I have a couple problems out of the textbook I'd like you to try. You can pause the video and try them, and hit play when you're ready to continue. Okay, so let's do number 4. Number 4 says 4w plus 2w equals 24. Well, I can combine these terms. I've got 2 w's on the same side of the problem. I can combine them together and get 6 w's. And now that's one step. The way I get rid of a times by 6 is divide by 6, and w equals 4. That was number 4. Number 5 says 8t minus 3t equals 35. Combine like terms, that gives me 5t equals 35. The way you get rid of multiply is by dividing by 5, divide by 5, these cancel, t equals 7. 4, 5, 6. Negative 16 equals 5d minus 9d. Okay, well, 5d minus 9d is, well, I can combine them together and get a negative 4d. And now, the way you get rid of multiply by negative 4 is you divide by negative 4. These cancel. D equals a positive, because the negatives cancel, a positive 64. No, I lied. I was multiplying. I'm not multiplying. 16 divided by 4 is 4. Number 7. I'm reading this out of the book, and I'm going to write it down as I'm reading. It says the output of the function is 5 more than negative 2 times the input. Find the input. Oh, so first off, that's equal to the output. So there's our equation. 5 more than negative 2 times the input. And we want to find the input when the output is 11. So when this output is 11, we want to know the value of this. So 5 a plus and a negative next to each other look kind of ugly. Sure, we'll do parentheses to make this a little bit prettier. Alright, so the y value is 11. So let's go through here. We're going to get rid of the add and subtract, so minus 5 here, minus 5 there. These cancel out. We get a negative 2x. This extra plus sign kind of goes away because it's still a negative 2 from what it said in the problem. And that gives us a 6. The way we get rid of times by negative 2 is we divide by negative 2. X equals negative 3. So my input was negative 3 for the given output. We've got number 8 to do. I can probably squeeze it over here someplace. Number 8. It says the output of a function is 4 less than, actually I have to think about that one. 4 less than 4 times the input. Equals y. Now, the reason why I switched it, I originally started to do 4 minus 4x. That's not right. Whenever you have a less than, you actually have to change the direction or flip-flop the two things you're subtracting. Because think about it. What is 1 less than 10? Well, 9. But if you do 1 less than 10 like this, 1 minus 10 does not equal 9. That's a negative 9. The way you get 9 is if you do 1 less than 10. That gives you 9 for an answer. So that phrase less than, you actually have to switch the direction of the two things you're subtracting. Now we can finish solving. And it says when the output is 3. Alright, so then we're going to add 4, 4x equals 7. That gets rid of this minus 4. We need to divide by 4 here, divide by 4 here, and x equals 7 divided by 4. Well, first off, that's a fraction that doesn't divide evenly. But we can turn it into a mixed number. 4 goes into 7 one time. With a remainder of 3, the denominator stays the same. That's about the best we can do with it. Alright. Now, the last example, we're going to be looking at some multi-step problems. So, here it says to rent a booth, to rent a booth at a county fairgrounds costs $42 per day, plus a one-time equipment fee of $85. Find the number of days Mr. Batzel rented a booth if he paid a total of $337. Well, first off, let's figure out what this guy has to pay for. He has to pay $42 every day, each day, plus he has to pay this equipment fee of $85 once. And that together would be his total cost. Now this, what I wrote down here, this is kind of like a verbal model. This helps you break down what the problem's saying in terms of some math and some words. The next step is to turn it into all math. So plug in stuff we know. Well, $42 each day. If you're doing something over and over and over and over again like that, it's multiplication. So this $42 each day literally does mean we're going to take 42 times by, and that's going to be our variable, x, because we don't know how many days. Find the number of days. We don't know. That's the missing piece. Plus $85, because we're paying that one time. We don't need a variable for that. And that gives us our total cost. Well, he paid a total of $337. So $42 each day plus $85 one time is our total cost. Look, we got ourselves an equation with one variable. Let's solve it. So I'm going to subtract 85, subtract 85. We'd get 42x equals, because this cancels out. And so we have to take 337 minus 85. Let's see if I can pull up a calculator here quick. Nice, I spelled calculator wrong. Alright, so we want to take 337 minus 85 equals 252. Okay. Now, divide both sides by 42. Divide by 42. These cancel. We get, oopsie, x equals 252 divided by 42. Clear, clear, clear. 252 divided by 42 equals, we got an answer of 6. So this guy rented for 6 days. We have our label. Let's just double check to make sure our answer makes sense. You could always check it by plug the numbers back in. If you paid $42 each day and then another $85, would that give you 337? Well, 42 times 6 would be this 252 guy plus 85 does equal 337. It works out. You can kind of think about it in your head just to see if it makes sense. If you take 42 6 times, that's like $250 right there. And then add 85, you'll get about 337. Alright. Number 6. Need some space. It says, a farmer has a field with 19 rows of pumpkins and a small side field with 12 pumpkins in it. Find the number of pumpkins in each row if both fields have a combined 107 pumpkins. Okay. So we have a field with 19 rows of pumpkins. So 19 rows plus a small side field with 12 pumpkins. Plus 12 pumpkins. And find the number of pumpkins in each row. So we don't know that. We need to find how many pumpkins are in each row. So that's going to be our variable. Find the number of pumpkins in each row if both fields have a combined of 107. That's our total. Okay, so let's turn this verbal model into an actual equation. Now we have 19x plus 12 equals 107. And solve. Minus 12 minus 12, these cancel. We get 19x equals 107 minus 12 is, I want to say 95, but I'll double check it. 107 minus 12, 95. And then we're going to divide both sides by 19 because that's how you get rid of a multiply by 19. Divide, divide, cancel, cancel. X equals 95 divided by 19. I don't want to do that in my head. 95 divided by 19 equals 5. Alright, got one more. Last problem here says Nathan is an avid stamp collector. For 9, or I would like you to do this one, but for 9 weeks he bought stamps. If we added those to his collection of 45 stamps, he now has a total of 252 stamps. How many stamps did he buy each week on average? Copy it down, do the problem, pause the video. When you're ready, hit play. Alright, so he's a stamp collector for 9 weeks. Let's see. So 9 weeks he bought stamps, plus he has another 45 stamps already in his collection, with a total of 252 stamps. How many stamps did he buy each week? So we want to find the number, how many stamps he bought each week. Okay, so 9, sure, leave it at W, plus 45 equals 252. Okay, so we're going to subtract 45. Subtract 45, we get 9W equals 252 minus 45. 252 minus 45 equals 207. Divide both sides by 9. W equals 207 divided by 9 equals 23. So each week he bought 23 stamps. Alright, so the last thing to do is answer the summary in the summary box. So how do you solve two-step equations? Take a couple of seconds, write it down. You should probably say something like, first thing you do is you get rid of adds and subtracts, then multiplies and divides. So get rid of, actually, we should do the combined like terms first. So first, I was going to say get rid of something, but we want to combine like terms. Okay, so first thing we do. Next, get rid of add and subtract. Finally, get rid of multiplies and divides. Look at us using our transition words. Okay, and there is the homework. Make sure you copy it down and do it, and have yourself a nice day. Thanks for watching. Bye-bye.